Hi everyone, I'm Lamp, and I made something. I decided to create a 3D clone of Tetris. So I started by giving it a name to the project. I went for Notris because it's definitely not Tetris. So what's the plan? I'm gonna generate a random block, make it move down over time. The player can move and rotate the block inside the game area. It's pretty easy, right? Wrong. When I decided to create this project, I didn't really think about how I would handle the collisions, which was the hardest thing about the whole project, but more on that later. So, I could have gone with the traditional way Tetris works, by creating the 3D versions of the blocks that are used in Tetris, but I decided to do something new, something that I haven't tried before, and create them randomly. I decided there would be a 3x3x3 block made of smaller 1 meter cubes. Creating the block was easier than I thought, even though while writing the script for the video I realized that I made a mistake. Basically, it works like this. I create an empty parent with a rigid body. I create the first cube that's always spawned. I create a 3D matrix of booleans that says whether a cube is in that position, and if there's one, there's a 50% chance that a cube is spawned in a neighbor position. A neighbor position is one with +1 in one of the indexes relative to the current index of the matrix. Basically, the position behind the cube, on top of it, or on its right. What I forgot to check is whether or not the position was already generated, empty or not. So usually blocks are chunkier than they should, because the script tries more than once to spawn in that position. I fixed the problem. Basically now instead of a 3D matrix of booleans, we have a custom enumeration that tells us if we already tried to spawn a cube, and if we did, if it was successful, so if a cube was spawned, or if it wasn't successful, so that position is empty. Knowing that, I know if I should try to spawn a cube in there, if it wasn't already tried. If there is a cube in that position, I can then try to spawn in the neighbor's position. And the movement was easy. I just moved the block without caring too much about collisions, hoping that Unity's rigid body will just handle things automatically. It didn't. But that's just more foreshadowing. I decided to use the WASD keys to move the blocks, and the arrow keys to rotate them. I also added a way to make the block move faster downwards, using the submit key. So at this point, the player can rotate and move around the blocks. For the game to work, there's just a couple of things missing. We need to detect when a block hits the bottom, check if one or more of the layers are complete, spawn a new block when the block hits the bottom, detect whether the player hit the maximum height. It looks like a lot of stuff, but all of this was actually done in less than 2 hours. Oh, and while I was recording this audio, I also discovered a bug in how I removed the completed layers, so you know what this means. Bug fixing time. Basically, when removing a layer, I move down all game objects. The problem with this is that I didn't check if a layer was below or above an object, so some cubes were moved down even if they shouldn't. To fix this, I just had to check what was the height of the layer and move down only the objects that are higher than that position. This took me way too long to figure out. Making the whole game took 17 hours of work, and the collisions took me around 8 to 10 hours of work. Here's a couple of things I tried. Just using a rigid body. I was trying to change all the possible values of the rigid body, but nothing seemed to work perfectly every time. Also, at first I forgot to remove the rigid bodies from the blocks that hit the bottom, so blocks were flying around like crazy. I tried to put box colliders all around the block and attach a script that would tell the block what direction was being hit. The problem with this was that the direction was static. This means that I wasn't keeping the rotation of the block in mind, so I had to find a new solution. I recasted from every side of each block before moving to check whether or not the direction was obstructed. This kinda worked and led me to the final method. The final method was, instead of using recasts, I used box overlaps, which basically works the same way, but detects collisions way more precisely. So, this is the end. The last thing I had to do was creating a logo for the game and a main menu, and the game was done. Thanks for watching. Check out the link in the description to play the game. Subscribe and like the video if you enjoyed it. This helps me very much with the channel. I am sorry if the quality wasn't very good this time. It's my first video and I still have some stuff to figure out. Hope to see you in the next one. Bye.